Hi friends, welcome to Easy to Learn channel. In this video I am going to explain about analogy between the vectors and signals. So first we have to see the vectors. So vectors are nothing but it is having the both magnitude and direction. That means consider two vectors v1 and v2. So in order to obtain the component of one vector along the other vector, the component of v1 along v2 is given by c1 to v2. And this component can be obtained by drawing a perpendicular line from the end of v1 and v2. So the vector of v1 can be expressed as, here the vector v1, it can be expressed as c12 into v2 plus ve. Ve is error vector, or we call it as an error approximation. So here this can be the component of vector v1 along the vector v2 is given by c12 v2. If the component along the vector, another vector is larger value, then the error is minimized. That means here the error value which depends upon the c12 component value. If the component of the vector v1 along the vector v2 c1 to v2, then the magnitude of c12 gives the similarity between the two vectors. Here if c12 is very large, then the error value is maximum. If c12 is minimized, means the error is also minimized. If c12 is equal to 0, if the component value is equal to 0, there is no component of one vector along another vector. So here if you put that component value as 0, the two vectors are mutually perpendicular, and those vectors we call it as an orthogonal vectors. So here when we call it as orthogonal vectors, if the component value c12 is equal to 0, then we call it as component orthogonal vectors. Here we have to write the component of v1 along the v2 in dot product. That means v1 cos theta is equal to v1 v2 by v2. That is equal to c1 to v2. So this is the dot product v1 v2 by v2. Here c1 to v2 is equal to, we have to equate these two, v1 v2 divided by v2. Here what is component value? v1 v2 divided by v2 into v2 dot v2. So these two are nothing but v1 into v2, it is not a v2 square. This is a dot product where here v2 is not cancelled because it is in the form of dot product, where v1 v2 and v2 are vector products. When v1 is perpendicular to v2, v1 will not have component along v2. So if these two, v1 is perpendicular to v2, here there is no component along v2. Then v1 into v2 is equal to mod v1 mod v2 cos theta. So if these two vectors are orthogonal, means what? The angle theta is perpendicular. That means theta value is what? 90 degrees. Then you have to substitute cos 90 degrees. Here the value as 0. That means the dot product of v1 v2 is equal to what? 0. So that is dot. Hence we can say here the two vectors are orthogonal when the component value is 0, or we call it as the vector v1 which is perpendicular to v2. Hence we call it as the two vectors are orthogonal to each other. So in the same way for signals. If you consider the signals, so we have seen the two vectors are orthogonal to each other. That is nothing but v1 v2 is equal to 0. So these two vectors are orthogonal to each other. Now we have to verify whether the two signals are orthogonal or not. Now consider two signals. We are considering the two signals here. One is f1 of t and second signal is f2 of t. So here if you approximate f1 of t in terms of f2 of t, that is nothing but f1 of t is equal to c1 to f2 of t plus fe of t. The same equation we can wrote in vectors. That is nothing but what? v1 is equal to c12 v2 plus the vector, error vector ve. So this is the same equation here we have to consider. That is nothing but f1 of t plus f1 of t is equal to c1 to f2 of t plus fe of t. Here fe of t is nothing but what? Error between the actual function and the approximation function with the interval. So when the error is minimized. So here f1 of t, which is similar to c1 to f2 of t. So with this equation, the error can be written as, from equation 1, how to write fe of t. So here fe of t is equal to f1 of t minus c1 to f2 of t. So in order to minimize the error, so what we have to do? So in order to minimize the error, take the average value of fe of t over the interval t is in between t1 to t2. Instead of taking the average value, we have to choose average square of the error. So in order to choose the average square of the error, we have to reduce the average square of the error. So the error the error is minimized. So here how to write error? That is average value and square. That is nothing but 1 by t2 minus t1 integration of t1 to. So here the t is in between t1 to t2 and fe square of t into dt. So e is equal to 1 by t2 minus t1 integral t1 to t2 f1 minus c1 to f2 of t whole square into dt. So in order to find if you find the c12 value, so how to find the c12 value? And this can be obtained by taking the differentiation of e and equating to 0. So we have to differentiate e with respect to c12 and equate to 0. So that is nothing but de by d c1 of c12 is equal to 0. So if you differentiate, what is e value here? This one. So this value you have to substitute here. So here we are substituting the error value. So this is the error value whole square into dt. So change the order of integration and differentiation. So this 1 by t2 minus t1 keep it outside, and remaining parts integration and differentiation with respect to c1 to f1 of t minus c1 to f2 of t whole square into dt is equal to 0. Now 1 by t2 minus t1 integral of differentiation of d by c12, it is in the form of a minus b whole square. So you have to write a square plus b square minus 2ab. So now if there is no component value, then we have to that value is 0. Now if there is no component value in the first equation, so this value is 0. So remaining parts integration to c1 to f2 square of t into dt minus integration to f2 of t into f1 of t into dt, which is equal to 0. So here in this equation we have to write these two. In this 2 is common, you have to common that one 2 and you have to send that 2 to right side part. So 2 by t2 minus t1 into 0, we get 0 value. So remaining part is what? Integration c1 to f2 square of t dt. So minus we have to send that side is equal to integration of f1 to into f2 of t dt. So here c12 is equal to, so this is a constant value, keep it outside. C12 is equal to what? This term, and remaining part is what? f2 square of t. So this is the component value. So when the two signals are orthogonal, what is the condition for orthogonality? That is nothing but the condition for orthogonality between two signals is when c12 value, this value is equal to 0. If this is 0, you have to multiply these two, you can get the 0 value. So that means integration of f1 of t into f2 of t dt is equal to 0. So this is the orthogonality of two signals. So when the component value is 0, then the two signals are orthogonal to each other. Thank you.